Good afternoon. In today's session, we are supposed to solve some numericals that will be on the three-phase induction motor. Firstly, we will revise the theoretical formula which we will require to solve the numericals. So we were studying about the three-phase induction motor. Induction motor means what? The AC motor, which will uses electrical energy and which will convert that energy into a mechanical energy. So we were using three-phase induction motor because these motors are widely used in a industrial as well as a commercial applications. Then we have seen about the construction of the three-phase induction motor. We can give the power supply in the star or the delta connections. Then we have seen there are different types of the three-phase induction motor like the squirrel cage and the slip ring induction motor. If we will require higher amount of torque at that time, higher amount of starting torque. At that time we can use slip ring. Otherwise we can use the squirrel cage because the construction of squirrel cage is very simple. But in slip ring we will require special slip rings and the brushes. So there is an additional part we will require. So now we want to see about the power equations that will be for the three-phase induction motor. So firstly we will see about the mechanical power loss because when we were giving the power supply to the three-phase induction motor at that time, rotating part will start to rotate, due to which it will loses the power. Roshan Vishwakarma joined the class on time. Okay. So here so here we were supposed to solve some numericals. That's why firstly we were revising our equations which we will need it to solve the numerical. So here we are saying when we will give the power to the when we will give supply to the three-phase induction motor, rotating part will start to rotate and there will be some power will get lost. So we can call that loss as a PML. It is nothing but the mechanical loss. So here when we are giving the power, giving the supply, that time total power will be PM will be equal to output power plus the mechanical loss, because some power will be used to do work done, that we are saying as a P out, and some power will get lost, that loss we are saying as a mechanical loss. So we can reconvert that equation and you can rearrange that equation in the form of P out. So your equation will become P out equal to total mechanical power PM minus mechanical loss power. So here we are saying efficiency is nothing but output power upon input power. So here we are supposed to see efficiency for motor as well as efficiency for motor. So efficiency of motor क्या हो जाएगा? The mechanical power which will get at the output of shaft, that is nothing but P output, and which we will get the power at the output of rotor, that is the PM mechanical power. So we can take that as a rotor output. Rotor input, we are saying rotor input as a P2, but here we are supposed to take motor efficiency. For that we will require in the denominator electrical input power which we are giving to the stator. So motor efficient का equation क्या हो जाएगा? P out upon P in. So here we are saying we can write the power in the form of torque and angular velocity like we were writing in the DC motor also. So we can write P equal to torque into angular velocity W. But W we can write 2 pi n upon 60 because W is nothing but 2 pi small n. But we are writing in a rotation per minute. So you can write 2 pi capital N upon 60. So here now we are having the equation that is the power. Is there any issue? Rishikesh, you are supposed to join class on time because we were solving some numericals. So you will get if you are attention. Okay, so see here what we are supposed to do here. Now we are saying about the power that will be in the form of rotor torque and in the form of angular velocity. So we are writing W into TG. This is the power. This is the power of the motor. But here we are saying power which we will give to the from stator to rotor. So that will be Tg into 2 pi ns. Ns nothing but the speed of stator upon 60. So we can write our total mechanical gross power Pm equal to torque into 2 pi n upon 60, the whole, the equation. This we can write as it is. So here we will get the rotor copper loss. That will be rotor power minus mechanical power. So rotor power we can take P2 minus mechanical power we can take Pm. We are having equation for both in the form of torque, in the form of speed. So we can write this. So we will get copper power. These equations you will be needed to solve numericals. Torque into 2 pi upon 60, and you can take an s minus n because both are having 2 pi and 60 are the common terms. So we are taking this common and we are writing in bracket n s minus n. Now we are supposed to see about the torque equation that will be in the form of mechanical power, copper power means copper loss, or we can say copper power, and in the form of slip. So now we are having the equation of a slip because here we are having the equation for power that will be in the form of speed and torque. But we can write ns minus n, we can write in the form of slip because we are having the equation ns minus n upon ns that will be equal to s. So you can write PCU upon P2, copper loss upon rotor power. That will be equal to, you can write equal to ns minus n upon ns, you can write s. So you will directly get P2 equal to PCU upon s. You can rearrange these equations. Only you will be needed how you can converting slip into speed, how you are writing power in the form of torque and the angular velocity, you will need these equations. After that you will get how we will converting this equation in this form. So here we are saying Pm equal to P2 minus PCU. So here we are having the PCU value in the form of P2. You can write S into P2. So you can write P2 minus SP2. So you will get Pm equal to rotor power in bracket 1 minus S. So now when we are solving rotor power, you will get the equations torque into 2 pi n upon 60. But here you can reconvert that equation in the torque, so you will get the torque equation. But here we are saying torque is directly proportional to the P2. So we can write torque in a synchronous watt that will be equal to P2 equal to PCU by S. So you will get PCU by S, but we can write PCU as a, we can write PCU as a PM upon 1 minus S because we are having here, you can see here PM equal to P2 1 minus S. So P2 को क्या हो जाएगा PM upon 1 minus S. So you will get here P2 in the form of mechanical power and slip. These equations you will be needed here. So we will solve some numerical. You can see here what is the question. A 6 pole, it means what? Number of pole, P equal to 6. 3-phase induction motor develops a power, mechanical power, PM equal to 22.38 kilowatt. KW is kilowatt, including mechanical losses. These losses is nothing but copper loss, rotor loss, the power loss. We are taking PCU, PML, mechanical loss. So we are saying here mechanical loss, PML, which total 1.94 to 1.492 kilowatt. So you can write mechanical power loss EML equal to 1.492 kilowatt at a speed of 950 RPM. So you can take that as a speed capital N 950 RPM rotation per minute on 550 volt. You can write V or you can write E equal to 550 volt. Okay. Now here they have given also frequency also 50 hertz means, so you can write frequency equal to 50 hertz. The power factor is nothing but you can write cos phi or you can write PF. Power factor equal to 0.88. नेटवर्क इशू हो सकता है बिकॉज इलेक्ट्रिसिटी आ जा रही है. यदि क्लास डिस्कनेक्ट हो गया देन यू आर सपोज टू ज्वाइन क्लास अगेन. ओके, सो हियर We are saying here power factor equal to 0.88. Abhishek, please mute yourself. हाँ. So here now we are supposed to find here calculate for this load. These questions will be asked in MCQs also. तुम्हारा एग्जाम ऑनलाइन रहे या तुम्हारा एग्जाम write up rahe, at that time also you will get the question, so you will be near this equation, so you please mute yourself. Abhishek. Okay. So
Yes,
here
ma'am.
I said please mute yourself. I'm making mute and again you are unmuting. Please mute. Okay. So here we are having the equation. We are supposed to solve sleep. They are giving us capital N. They are giving S frequency. So we are having two equations for sleep. S equal to Ns minus N upon Ns. But if we are not having Ns, you can find Ns. How? 120F upon P. These equations you will be needed because there will be questions on numericals. Also, there will be questions on only for this equation. S equal to Ns minus N upon Ns or N minus Ns upon N. So these equations or ये 120Fp, this will also useful equations. This will also need. So you can so here, what we are saying, f is equal to 50. They have given 120 as it is 50. We are having because they have given f equal to 50. P number of pole. Number of pole they have given 6 pole. So you can write. You will get the value that will have unit rotation per minute because we are writing here capital here. Unit will have half mark. You are supposed to write the unit. After that, sleep. Sleep is the ratio. So there is no need of unit. We are having the equation ns minus n upon ns. Ns we have just solved 1000. And they have given 950. So 1000 minus 950 upon 1000. So you will get 50 upon 1000. So you can write 0.05. Now you are supposed to solve for the second is the rotor copper loss. It means what? PCU. Huh. So here we are supposed to solve. I have already written the same things they have given. We have written here also. So you can observe here. We are supposed to find PC. So now we are having the equation for the PM. That is nothing but mechanical power equal to P2 1 minus S. We are having value for S. So you are having the value for mechanical power PM. So you can solve this. So you will get the value for rotor power P2. You will get P2. If you will get P2, you are having the formula for PCU S into. My screen is visible.
Yes, ma'am.
Okay. So what we were solving the second term. This is the rotor copper power loss. So we are having the formula PCU equal to S into P2. P2 we are not having. So we can solve firstly P2 because we are having the equation for P2 that is PM upon 1 minus S. PM है, S का value हमने just solve किया है. Mechanical power they have given 22.38 kilo. So you can write 22.38 into 10 raised to 3 or you can write kilowatt upon 1 minus yes. Yes ka value we have just derived 0.05. If you solve this, you will get the value that will be 23.55 kilowatt. After that, you can put the value of yes 0.05 P2 23.55. So you will get the value for PCU that will be 1.17 kilowatt. Now, we are supposed to find total input power. That will be rotor power plus the stator losses. So here they have given rotor power we have just solved. What we will get here? Rotor power P2 23.55. Stator losses 2. So we can put this value. So you will get 25.55 kilowatt. Now we are supposed to find efficiency. Efficiency का formula क्या है? We are supposed to find the efficiency of motor. So that will be output power upon the input power. So input power we have just solved 25.55. Output power here We can solve output power because now we are having the mechanical power, we are having the mechanical loss, Pm minus loss. So you will get 22.38 minus loss is 1.492. So you will get the value 20.88 kilowatt. If you will put all these values for the P out and P in, and if you will multiply with 100, you will get percentage efficiency. If they are calling about the efficiency, you can write only 81.8 or you can write 0.81. But if they are talking about the percent, so you are supposed to multiply, so you will get 81.8. Now, we will see another one problem. No, there is one is remaining. We are supposed to find line current, IL. So we are having the equation for input power that will be in the form of power factor cos phi. They have given here. We are writing PF or you can write cos phi. We are supposed to write value of square root of 3. You can write 1.7312 or you can write as it is. You can solve on calculator. P in we are having because we have just solved. We will get P in 25.55 kilowatt. So you can write 25.55 into 10 raised to 3 watt. Now we are supposed to find IL. So IL का equation क्या हो रहा है? If you are reconverting equation in the form of IL, you will get IL equal to P in upon square root of 3 VL cos phi. तो हमारे पास सारे values है. You can put because they have given us input voltage. That voltage you can take as a VL. So you will get here 25.55 into 10 raised to 3 upon square root of 3 into 550 into 0.88. So you will, if you solve, you will get here equality sign is required. You can put here equality and you can write 30.4 ampere. That will be the value of load current. Now we are supposed to find the number of complete cycles of the rotor electromotive force per minute. It is nothing but you are supposed to find the rate, the number of cycle complete per minute. It means what? You are supposed to find the rate. R equal to, we are writing S into F, or you can take FR. You can take R equal to SV, or you can take FR equal to SF. Only the term which we are using, you are supposed to understand the meaning of that. This is nothing but they have given here, you are supposed to find the number of complete cycles of the motor. It is nothing but you are supposed to find here rate. So that will be FR equal to S into F. So we are having the frequency 50, S we have solved 0.05. If you solve this, you will get 2.5 hertz. And if you are writing per minute, so you can take half of that, twice of that. So you will get 2.5 into 60. So you can say per minute. You can write in any. You can write in per second or you can write in a per minute. If you are multiplying that value with 60, you will get the value per minute. Now we will solve another numerical. Here also the same things we will be reading. They have given a 37.3 kilowatt. So it is the power. You can take, but which power? We are supposed to understand. A 37.3 kilowatt, 4 pole. 4 pole you can write P equal to 50 hertz, you can write frequency. Induction motor has a friction and windage losses of 3320 watt. So it is nothing but it is the loss. So you can write mechanical loss PML. PML equal to 3320. So they are saying here about the loss. So that will be the output power. So you can take P out equal to 37.3 kilowatt. Stator losses equal the rotor losses. It means what? You can directly write P2 equal to PS. It is nothing but stator loss, or you can take PSL. And rotor loss, that will be P2. So here they are saying, or you can take PCU also, because copper is in the rotor. So we can take PCU or you can take P2. So here, if the motor is delivering full load at a speed 1440 rpm, so you can take capital N equal to 1440 rpm. You are supposed to find synchronous speed. Synchronous means ns 120f upon p. So we can solve synchronous speed 120 F upon P. P they have given 4. They have given here P equal to 4, F equal to 50. If they are not giving frequency at that time also, you can take 50. You can take here 50 if they are not giving, because if they are not giving, you can consider this. जैसे हम pi का value 22/7 1.414 we are considering like this. You can consider here frequency as a 50 hertz if they are not giving, but they will 99% they will give the value. So here you can take 120 into frequency 50 upon pole 4. So you will get the value for the synchronous speed, that will be 1550 RPM. Now you are supposed to find sleep. We are having all the values. We are having n value 1440 RPM. Ns we have solved. So 1500 minus 1440 upon 1500. If you solve, you will get 0.04. If you are writing in percent, you can write 0.04 into 100. That will become 4%. Now, you are supposed to find mechanical power. That is nothing but PM. We are having the formula PM equal to P out plus PML. P out they have given 37.3 kilowatt. PML PML they have given 3320. So you can write 3.320 kilowatt. So you will get P out plus PML, that will be 40.62 kilowatt. Now you are supposed to find rotor copper loss. Here we are saying rotor copper loss, that will be equal to stator loss. We are having the formula PCU, that is nothing but rotor loss. Rotor power loss upon PM equal to S upon 1 minus S. PM we are having mechanical power, they have given 37.3. Mechanical power we have just solved. We are having the value 40.62. So we can write here 40.62 into yes slip. We have just solved here. Slip value 0.04. So you can write here 0.04 upon 1 minus 0.04. If you solve this, you will get the power loss, that will be 1.692 kilowatt, or you can write in the watt 1692.5 watt. Now you are supposed to find the power which will be transferred from stator to rotor. So that will be P2 equal to PM plus PC. PM we have solved 40.62. PCU we will get here 1.692 kilowatt. If you solve this, you will get that addition, that will be 42.312 kilowatt. Again, we are supposed to find here stator input power. We are having the formula P in equal to P2 plus P stator loss. But here we are taking that is as a PCU. So we can take PCU 1.6925. P2 we are having, that is the 42.312. So you can write this value. So you will get 44.0045. Now we are supposed to find efficiency. Efficiency output power upon input power. If you put these values for output power, input power, you will get efficiency, that is the 84.76%. Again, we can see another example. It will be also similar. We will share this PPT with you. You can practice yourself at home. Here they have given an 18 kilowatt. That is the output power, 4 pole, number of pole, P equal to frequency 50 hertz, 3-phase induction motor has a friction and windage loss. That is the mechanical loss. They are saying sometime any loss, but that will be the mechanical loss, friction and windage loss, or they are saying directly the mechanical loss. So you can take PML equal to 500 watt. The full load slip, they have given here slip value S equal to 4%. So you can take 4% or you can take 0.04. Compute for the load. Rotor copper loss you are supposed to find. You are supposed to find rotor input. You are supposed to find gross torque. You are supposed to find shaft torque. We will solve one by one. We are having the equation for rotor copper loss. This is the rotor copper loss. and P2 is nothing but only rotor loss. So we can take here PM mechanical power equal to output power plus mechanical loss. So we will get 18 plus 0.5 because they have given here 18 kilowatt and they have given 500 watt. So 500 watt को तुम kilowatt में you can write 0.5 kilowatt. So you will get mechanical power that will be 18.5 kilowatt. Now you are supposed to find PCU. We are having the formula PM into S1 minus S. So here you can write S value because they have given 4%. So you can write 0.04 because 4% means 4 by 100. So you can write 0.04. 18.5 into 10 raised to 3 because kilowatt की जगह we are writing in a watt into 0.04 upon 1 minus S 0.04. If you solve it, you will get 770 minus 770.83 watt. Now, you are supposed to solve for rotor input. It means what? P2. So here we can solve P2, rotor input power. P2 is nothing but input power. And PCU is the rotor output power, or we can say power. So here we can solve P2, that will be equal to PM plus PCU. So we are having the value for PM. We have solved value for PCU. So you can write PM plus PCU. So you will get here value as a 19.270 kilowatt, or you can write 19270.83 watt. Because they have given here output power, we are having the copper power. If you are writing, you will get the value. Now, the shaft torque. Shaft torque is nothing but you are supposed to find the torque value. We are having the value equation. Torque equal to P out into 60 upon 2 pi. For that, you will be needed the capital N. How you can solve? You are having the equation for NS, 120 F upon P. F we are having, P we are having, we can solve. We are having the NS equation in the form of N. So you will get the value for speed. So you can solve firstly NS 120 into F50 pole 4, you will get 1500 rotation per minute. And NS upon NS into 1 minus S. So you will get 1500 into 1 minus 0.04. If you solve this, we will get the value 1440 RPM. Now, we are having the all value. P out they have given 18 kilowatt into 60 upon 2 pi, and we have just solved. If you solve this, you will get the value for the torque, that is 119.36. We are having the unit Newton minute. You can write Nm. Capital N is nothing but Newton. So here we are supposed to find gross torque. There will be sometime MCQ that will be on unit. You will be needed this unit. पावर के लिए हम वैट यूज कर रहे हैं लाइक दिस यू विल बी नीडेड दिस यूनिट ग्रॉस टॉर्क वी आर हैविंग ग्रॉस टॉर्क pm into 60 upon 2 pi pm we have just solved here pm we have solved 18.5 kilowatt so you can write that as a जैसे यहाँ पे लिखा है we can write 18.5 into 10 raised to 3 watt into 60 upon 2 pi and 1440. If you solve this, you will get the value for the gross torque, that will be 122.68. Here we have finished the numericals. Remaining part we will see in the next session. Now I am taking your attendance. If anyone is facing any issue in numericals, you can ask me. You guys can leave now. Thank you.